Welcome back to Black Robot. In this chapter, we are going to learn about one of the most powerful features in C programming, that is functions. Quick question. Do you like writing the same code again and again? Of course not. Fun- Functions help us write once, use many times. So there's the functions. So functions are blocks of code that performs a specific task. They make programs modular, easy to understand, and reusable. Imagine if every time you needed to print something, you need you had to rewrite the whole printer function. Functions save us from that headache. So no need to write again and again, right? So that's why we need the functions there. So what is the advantages of functions? Functions gives us reusability, write once, call many times, readability, program looks neat, debugging, easier to find errors, teamwork. In large projects, one person writes one function, another person writes another. That's how big software like operating systems are built. So if you're seeing here, this is the syntax of function. So here you write the function name and parameters, the argument which you pass from this function, and the body of the function you will write, the action performs inside that body, and return the final value which you want to return into the main function from where it is calling. So a function must be declared, defined, and called. Okay. So in that case, uh, so every time function has three steps: declaration, definition, and call. So what is declaration here? It telling the app you want a cab. So think about the booking a cab here in that perspective, how it is going to perform it, right? So for declaration, you telling the app you want to book a cab. Definition, driver accepting your request and coming. Call, actually riding the cab there, right? So this is what these three words means here. Declare, declaration, definition, and call. Okay. So you can relate all these three with real-time examples. You can think more about that, how it performs. Okay. So for a function flowchart, if if you'll see here, okay, so into the main it has gone, okay, so the main function will initialize, then function will call up here, then it goes into the main the call up function, and it will return the value, and when it will return the value, it will back into the main function. So this is what the flowchart means. So so in that case, main function starts execution. Then function you call up, then control jumps to the function, it executes and return back. So either it can return with the value, either it cannot. Okay, it depends upon your implementation, how you are doing. So this is what flowchart happens, right? You have to keep in mind how function is performing because there you are going to use multiple functions. So you are going to call up into the main function those multiple functions. Okay, so this is what. So see already here library functions in C. What is library functions in C? So that those are predefined functions which is available into the header files. So header files we already example we talked about stdio.h. So similarly you will find many rows. So like for string.h. Okay, so this kind of predefined libraries you will find. So, so in that case, you can call up these predefined functions and you can save up time and you don't need to, write everything from a scratch. So these, like printf, right? So printf, you are calling this is the predefined functions. Scanf is also there, which you have already studied. So in that case, commonly used libraries and functions, we will talk about more there. So into the stdio.h, if you see, printf, scanf, get char, put char is given there. Okay. Then math.h, if you're seeing security, pow, abs, seal, flow is given there. Okay. Then string.h, str copy, str ln, str cmp, str cat is given there. For stdlib, also you are seeing the main uh, stdlib is given, malloc, free, rand exist is given there. So these are dynamic memory allocation. Later we will study about as well. Time.h, when you want a time to just read it, and also you want to create a timestamp there. So time and clock, these kind of predefined use library is given there. Ctype.h is also there. Is details is alpha, two upper, two lower, these kind of things for it is given there. So later, we will study more about that. What is printf? So printf is basically prints formatted output and to screen. So we have already seen that scanf reads input from user. We have already used this predefined functions. And getchar reads a single character from keyboard. Putchar prints a single character to screen. Okay. Into the coming to the math.h, sqrt is given for square root of x. Okay. And pow uh, is given for raised to the power b. So suppose pow you have given there. Okay. So a to the power b. This is how you defined it. Then ABSX, ABS is given there. So absolute value of integer, when you wanna find out, you will get it. So seal is there. So in that case, you call the integer. So it goes for the smallest integer, which is greater than or equal to x. So it's basically round up the things. So floor x, largest integer, which is less than or equal to x, which also round down the the integer value there. So coming to the string.h, str copy, which is copy one string into another. Length of string, we use for the strlen when you want to just uh, want to know the length of the string there. Then strcmp when you want to compare the length of two strings. So it returns zero if equal, that is. So strcat is here. It concatenates two strings there. Okay, it joins. It means it joins there. Coming to the stdlib.h, it allocates memory dynamically. We will, you know, read later. Then free allocated memory. Then rand it generates a random number. Exist, it terminates the program. Coming to the time functions, time is null. Current time is basically you will know about here uh, there current calendar time, and clock is processor clock exits. Coming to the int digit, checks if character is alphabet, is alpha, check if character is, sorry, for my bad, if it checks the character is, if it is digit, is alpha, if it checks it is alphabet, to upper converts character to uppercase, and to lower, it converts character to lowercase. Okay. So if you're seeing here math.h we have used, so how you are using 25 is sided into the sqrt, though it means 5 because it's a square root of 25 is 5. Okay. So this is how you will know more about that. So coming to the next one, user defined functions here. Okay, it is created by the programmers basically. So in that case, uh, In that case, for a specific task, it's created by the programmer, and also it useful whenever you don't resolve your exact problem. Okay, so in that case, how define it that we are going to use later for these user-defined functions. So in that case, four types of user-defined functions we basically use it. So, later we will study about it. So before that, how function declaration is happening, we need to check here. Especially when you are seeing. Okay, so if you are seeing here, in that case, you have just called the header files, then white grid as a function declaration you are doing. Okay, in add a plus b because later we are going to do this. So this is function declaration, how we basically use it. Okay, so white grid here you are using the same white grid you will just do as a function declaration and in digit as well. Okay, so this is how you are going to use it. So you will just initialize the main function. Okay, so the greet function will call greet this symbol. So in that case, the bracket will open and close, we'll use it. And function call, whenever it will happen, it will come here and it will print the hello world. So this is without the return one, but it will print of the hello from a function. Okay, then after that, you are function call with argument you're using, you are passing five and three, two arguments as an integer, int a and int b. So it will just sum up a plus b here, it will return the value and store into the result. So what will happen? 5 plus 3, it will become 8 here. So it will sum is equal to, it will become 8 here. Okay, so this is how the function works. So you can make many functions, and also this white grid you can use. Suppose in you have made white and some other function name as a ABC. Okay, so in this function also you can call as a grid here, and you can see. So in that case, ABC you are calling here A, B, C. Okay. So it will call here again, it will go into the greet and it will just print it, this one. So this is how user-defined functions works. So I think you have got the clear picture for that and how, user-defined function returns. So in that case, we will talk about no argument with no returns here, argument no, then argument no return, then no arguments with return, argument with return. So this is four type you are seeing here. Okay. So it helps build flexibility into the programming. So no argument, no return. How you call up this thing? So you initialize with the int main, then call the function call where you are just printing here. You are not returning anything, and you are also not passing any argument. Okay, so that's why it is with the no argument and no return here. And arguments with the no return, if you're seeing here, you are passing the argument 5 and 3 into the function call. It has come up here and it is adding and printing it, but it is not returning anything into the main function. Okay, so that's why it will not come here and sum up. So it is printing it to the this print sum only here. Coming to the addition function, so this is what how it works. Okay. So in that case, coming to the addition, okay. So one more no argument with return if you are seeing. So we will talk about as well. No argument with return. Okay. So no with return. Okay. So in that case, what will happen here? So suppose you have given void sum. So in that case, nothing will come, but it will a plus b, a is equal to 3 and b is equal to 4 you have defined. So c is equal to a plus b you have given. So return you can make as a c. So here you are not taking anything, right, as an argument, but you are returning this. Okay, so in this no argument with no with return, and argument with return is well, similarly if you are wide subtract you are doing my my bad. Uh, wide subtract. So here we got int A, int B. So we got these two values. Okay, so C is equal to A minus B, and we got C. So this is what with the argument on return. So this is how you will define it. Okay. Coming to the addition function, the so here the function returns A and B are with the argument. So this is what example we have just talked about. We are having argument and returning A plus B with. So this is what function returns with the sum of. And coming to the factorial function, if you are seeing here, okay, so it is calling it A is equal to 1 for this if you call up this factorial, so in integer suppose you have got 4, right? So this 4 and you will get it here, and you will initialize with the fact one. Okay, so always whenever I is equal to 1 happen, I plus plus will go, so 1 into 2 into 3 into 4, because you have got 1 here. Okay, it will come as a 1, and 1 is less than is equal to 4, it means it's true. Okay, 1 into fact 1, 1 into 1 it has happened. Okay, then it will increment here, it will become 2. So again, it is comparing here, then what will happen? Okay, so in that case, again, it will come because 1 is already stored into the fact, 1 equal to 2, 1 into 2. Then 2 is stored, then 3 into 4, like that way. So it will return the factorial value to this one. So just now we talked about no arguments with return, arguments with return as well. So this is how it happened. Okay. So now coming to the main, because you will be using in many of the functions recursion as well. So into the recursion, how it works. So in that case, the function calling itself. So it means so it means whenever the function is happening, you call the function there. So that function is calling itself until the function is not, breaking there. So it is useful for programs like factorial, Fibonacci series, street traversal, etc. So in later, we will go into in later videos about data Infinity factorial as well. So, but here, if you are seeing what is factorial function in that case, okay, so it's a iterative loop based, and also it recursion because function is calling itself. So in that case, what is happening if you are seeing here, you will call this factorial into the main function. The function will you will pass an integer and value this one, because suppose 4 you have called, right? 4 is not equal to 4 is equal to 0. It means it's a false. It will not return value. So it will come here 4 minus 1. Okay, so it will become is equal to 3. Then again it will call up. Okay, it will become here, but here you are seeing n is already multiplying, so 4 is already there. 4 minus 1 into 3. Okay, so 3 will pass up again into the factorial, it will come here. So 3 will match up. Yes, it is not equal to 0, so it will not return 1. So again it will come 3 minus 2, it will become 1. So similarly, it will iterate until it will not become to 0. So when suppose it has become 0, okay, so 0 is equal to 0 0, so it will return 1. So it means it will break the recursion here. Okay, so this is how it will work for the factorial. So function is keep calling itself until base case is not, the base case is becoming n is equal to 0 here. So what is the real time analogy here? Think of an ATM machine. It has a modular functions like check pin, withdraw, deposit, check balance. Okay, each task is a separate function. This is modular programming in real life. So, in that case, you can try yourself how check pin is happening. You can call into the main function and call it here. And for withdraw as well, you can do the same. You can write your own function here for deposit as well, check balance as well, and you can call it into main function here. Okay, so when you will be calling, so here all the call will happen for this. Okay, so in that case, it is easy. Is each task will be modular, making the system as a simple and organized. So because you have not just just mess up all the things here, and it would be easy to understand where the actual task is happening, in which function it is happening. Okay, otherwise if you are written into the main function, it will just mess up for everything, so it would be difficult to understand for anyone how the task is happening for all the functions here. Okay, so this is what a real time analog for ATM function. You can try yourself about these things, and if any question is here, you can comment in below comment box about these things. Okay, and ATM solution, yes, this is what we have talked about. Okay, so into the checkpin, what you can do, you can verify the user. Okay, into the withdraw, what you can do, you can twice withdraw, and twice deposit function, you can make it balance, check balance. So like that you can make it. Function calls and stack memory. Each function call is stored into the stack memory. Okay. So every function call uses the stack memory. In that case, local variables exist only during function execution. After return, memory is freed. So this is what I think you remember in last to last lecture we discussed about the memory about right. So there, whenever the local uh, variable is there, so that exists within that function only. So this applies for the this is what we are talking about. So the local variables exist only during the function execution. After return, the memory will be freed for from there. Okay, so recursion uses the stack for each call. Okay, so recursion always use for the stack, go for the stack memory there for multiple calls. So when you are doing your implementation, please make sure stack memory should not be full during recursion time. Okay, so this always goes. So why we you know keep in mind always about this. So here into the embedded uh, programming, stack is less, right? Stack memory is less there. So in that case, we try to avoid these recursions there. Okay, if that is so much less, we are not having, so much memory, we have limited memory. So we always keep in mind where recursion we are going to use it. I think you have got it about the recursion as well, how it is happening. So recursion is calling, function is calling itself within the function there. So this is what recursion is there. So best practices for function is that keep function small and clear. Okay, always keep in mind. Use meaningful names. Do not, write it like A, B, comma C, like these functions. This is not having any name, right? So you have to give any meaningful name to just to get it what exactly that function is going to do. And avoid global variables. This we have talked about already in previous lectures. So avoid global variables always and use instead of reiterating. So this is why we are going to use the functions here. Avoid reusing. Okay. So this is how you can make reusable code. Okay. So, and for example code, so this is rectangular there. So in that case, how rectangular you are going to use rectangle area. So in that case, has program three different functions you have seen, right? Get input for imply, int w for weight, get input, then enter for calculator. So when you have enter for L and W here, okay, so you are just passing these arguments here, right? Calculated area. So it have got here, so L into W, you have got it, right? And get input you are calling, so in X scanf, you are just taking these numbers here. For display, also you can use the display result. Okay, so this is how you are using. Okay, for W also we are using get input to get the into the value from there, and when you will calculate it, you will display the result. So for display result, we have made one more function here, int area you are passing, so it will just print the area, and because this L into W will come into the int area is you are passing here. Okay, so this is how you can make more readable code here using the multiple functions. Okay, so let's see about the interactive quiz here. So you can write your answers into the comment box. Which library contains SQRT? Which function copies strings in C? Can a function return multiple values? So I will be happy to see these answers into the comment box. Okay, so hint is also given that you can use for free. It's up to you. Okay, so summary. So functions make code modular and reusable. Libraries gives us predefined functions. User-defined functions let us solve custom problems. So four types of functions without arguments and returns values. And we have studied also real-time analogy shows why modular design is powerful. So question for you from everyone here, which type of function would you use to calculate the area of a circle with arguments with return or and no arguments and no return? So comment your answers in the next chapter. So let's wrap it. Thanks for everyone.